Okay. This is chapter 8 topics. It's question 1 to 5, 5 questions, 3 pages. You know what? Okay. List the raw materials that are used in the industrial manufacture of H2SO4. Sulfuric acid, we need just sulfur and oxygen, no? Sulfur and air. Okay, yeah. List the conditions used in the contact process. The conditions used in the contact process are 450 degrees Celsius and 280 M. If it was in kPa, it would be 200 kPa. Okay. And did they say catalyst? Yeah, okay. The catalyst used is vanadium 5 oxide. And they said use an equation, write an equation for the catalyzed reaction. It's to get SO3. Why do you use a catalyst? For equilibrium, okay? So 2SO2, remember, let me open the chapter 8 notes. So the one with the one to produce SO3, it's an equilibrium reaction. Okay, so this is the one that needs the شو اسمه the catalyst. And I memorize SO2 plus O2 to produce SO3, and then just to balance it, just put like a 2 here and then a 2 here. Okay, أكيد it's gas. Okay. This is easy يعني. Okay, memorize this stuff. Okay, the catalyzed reaction is the one to get SO3. Okay, the equation for the second step in the contact process is this. Oh, okay. The percentage of sulfur, guys, you should go back and read over the sulfur notes after the contact process. Okay, أول شيء you start like this to get SO2, then SO2 plus oxygen to get SO3, and then you add H2SO4 to get oleum, and then when you add water to oleum, you get H2SO4. The percentage of sulfur trioxide in the equilibrium mixture changes with temperature. Okay, so percentage of sulfur trioxide, as you increase temperature, the percentage of sulfur trioxide decreases. How does the percentage of sulfur trioxide change? Okay, we just said as you increase temperature, sulfur dioxide decreases, right? So increasing decreases, yeah. Percentage of sulfur trioxide decreases. What is the effect of increasing temperature and increasing pressure on the position of equilibrium? So here we just found out that an increase in temperature would cause a decrease in the yield, right? So an increase in temperature would cause a decrease in the yield. Then increasing pressure, it always goes to less gaseous moles, right? So this is gas. If you increase pressure, the system will want to decrease the pressure, so it goes to less gaseous moles. So it's gonna go to the forward, to increase the yield. Let's check the answers. Increasing the temperature favors the endothermic reaction, so it goes to the left, right? Favors the endothermic. This is exothermic because you're building bonds, so it's exothermic. This is exo. Memorize that both the Haber process and the contact process are exothermics, okay? Okay. Shifts to the left. Okay, and increasing the pressure goes towards the lower number of gaseous moles, which is to the right. Increases the yield. In the following reaction, is the forward reaction endo or exo? You can, حتى without knowing, you can say it's exo. So I want to see the reason they put exo. Yeah, because if you increase the temperature, yield decreases. That means the endo is backwards. Because when you increase temperature, it favors the endothermic, right? And since yield decreased, that means it went backward. That means the endothermic is the backwards reaction. That means the forward is what? Exo. Because it was given here, huh? The increased temperature with a percentage went down. Question D, no, C. The temperature is 450. Explain in terms of rate and percentage yield why this temperature is used. Rate, if you increase the temperature, the rate will increase. And percentage yield, you can't increase it too much. You have to say you can't increase it too much because if you increase it too much, as we said in part A, the yield will decrease. So that we had to compromise and choose 450. So look, this temperature is low enough for a good yield and high enough for a good rate. Explain how sulfur trioxide is converted to concentrated sulfuric acid. Complete the okay. Sulfur trioxide SO3. What do we add to go to sulfuric acid? أول شيء, remember, you add sulfuric acid to get oleum. to get oleum. Okay, then you take this H2SO7 and add H2O to get 2H2SO4. So I want you to say it's reacted with more concentrated sulfuric acid to produce oleum, and that oleum is reacted with water to produce 2H2SO4. So let's see here. Bubble sulfur trioxide into previously concentrated sulfuric acid, then add the resulting solution to water. Complete the following equations. To get H2S2O7, to get oleum, what we add sulfur trioxide to, we always add it to sulfuric acid, and then sulfuric acid to get H2SO4, it should be H2O. This should have a 2 here, it should be balanced. Consider the following equations that show a possible route for the formation of sulfuric acid as part of acid rain. So, acid rain has sulfur dioxide in it, okay? Very, very important that you memorize this. Which of the two equations above represent a redox reaction? Previously, you were not required to know this, but now you need to know this. A redox reaction. The easiest method for me for redox reactions is to take a look at the oxidation numbers, okay? SO2. And now take a look here. It was 0 because it's a compound, right? Then it became 0. For a redox reaction, basically what happens, and this is a very, very efficient way for them, whenever they ask you which of the following is a redox reaction, use this method. It's the easiest way. Don't look at oxygen, don't look at charge. This is the best way. Look at the oxidation numbers. We wrote a table for all the oxidation numbers over here. When did I do it? 25, I think. Yeah, here. Oxygen is very important. You know it's -2. Okay, so over here you have the total. Since if there's no charge written, then its total is 0. Okay, oxygen here 2 times -2 -4. Sulfur, to get 0, how much does it have to be? +4. So the total is 0. There's -4 from the oxygen, so obviously sulfur has to be +4. Let's look at SO3. We know that it's each oxygen is -2, so 3 times -2 is -6. So to get the 0, the total overall charge of 0, how much does the sulfur have to be? +6. Okay, so let's take a look. Sulfur was +4, it changed to +6, so it increased. If it's increasing the charge, what does that mean? Oxidation, right? Oxidation half. Now I need to see the reduction. Was anything else decreasing? Yes. The charge of oxygen was -4, it became -6, so that's decreasing. So that means that's reduction half. So we have oxygen half, reduction half, so that means the first one here is oxidation reduction. So it's redox. Let me prove to you that B isn't. Let me show you here. O3, again, its total charge is 0. That O3, each one's -2, so it's gonna be -6 for O3. And since it's -6, to get 0, how much does sulfur have to be? +6. Okay, this is oxidation number of sulfur and oxygen. طيب, let's take a look here. H2, each H is +1. So 2 times +1 is +2. S, we don't know. And 4, it's -2, right? -2. -2, so the 4 is -8. Then S here, how much is it? 2 minus 8 is -6. So how much does the sulfur have to be here? +6. So that means the sulfur here was +6. The sulfur here is +6. Did it change? Did it change? It did not change, right? So that means this one here is not redox. An alternative way to produce acid rain is through the reaction of SO2 with water first, then through the reaction of the product with oxygen gas. Write the two equations that are involved in this process. طيب. I'm gonna put this for you. Okay, here. Okay, B. Sulfur dioxide with water, SO2 plus H2O, will get you H2SO3. Just add an oxygen and H2. It's going to be H2SO3. This is a diprotic acid that is weak. Okay, this is sulfurous acid. In case they ask, this is a weak acid. Then they said, then react it with oxygen. Just add H2SO3, add oxygen. You're going to get H2SO4. This is a strong acid. This should be the... Yeah. Question 4, I think it's a contact process. H2SO4 is manufactured by the contact process. After reacting molten sulfur with air, the sulfur dioxide gas SO2 is mixed with more air to produce more sulfur dioxide gas. Give the chemical equation between sulfur dioxide and air to form sulfur dioxide. SO2 gas plus half O2 gas to produce. This is a reversible reaction, SO3 gas. If you want to multiply the whole equation by 2, you're going to get 2 and 2 here. The 2 here cancels. You can get that, but I don't know, depends on what they ask. If they say small numbers, you use that. See here, they got that. In the written adi, you can write it with the half, it's fine. What are the conditions? What are the conditions? You know, it's 280 M and 450 degrees Celsius, and the catalyst is vanadium oxide. Okay, they get this every exam. Okay, Hata this one, they get it every exam. The manufacture of sulfuric acid by the contact process is done through the following reaction. Sulfur is changed to sulfur dioxide gas, either by burning sulfur in air or burning, what were they? See here, this was sulfur notes. Yeah. In the first step, you get, yes, to get SO2, you can either burn it in oxygen or roast sulfide ores. Okay, there are 2 ways to get it. I advise you, if you're studying from the periodic, to go back and watch the CA quizzes. This was, I think, term 1 week 4, term 1 week 5. Okay, so sulfur is changed to sulfur dioxide gas. Sulfur dioxide combines with oxygen forms sulfur dioxide gas. We did it just before the question here. 2SO2 plus O2 gas, 2SO3 gas. Okay, this step is reversed when the catalyst uses speeds up. Here we add vanadium 5 oxide. Sulfur trioxide is dissolved in concentrated sulfuric acid solution, oleum, forming sulfuric acid H2S2O7 forms. A fuming sulfuric acid H2S2O7 forms. We dissolve this in, then you take SO3 plus H2SO4 to get H2S2O7. This is the whole contact process. I'm just saying it over and over again. I'm just repeating it so you guys can be reminded. Oleum is then diluted with water from concentrated sulfuric acid. Then you take this H2S2O7 and you put it in water, and we get to H2SO4. This is the contact process summed up. And the conditions, I'll write them on the side. 450 degrees Celsius, 280 M, or 200 kPa. If you memorize all this, you're done for the contact process. You're done for the sulfur. Define a catalyst. Name the catalyst used in reaction 2. A catalyst is any substance induced that speeds up a chemical reaction without being used up. And the catalyst here, what is the catalyst here? It's vanadium 5 oxide. Okay. Write a balanced equation for reaction 2. We just wrote it all. I wrote it here. 2SO2 plus O2 produces 2SO3. Write a balanced equation for reaction 4. Oleums and diluted water form concentrated sulfuric acid. It's right here. And then in reaction 2, less sulfur trioxide forms at a higher temperature. Specify whether reaction 2 is endothermic or exothermic. Let's see. If you're increasing temperature and they're saying that yield decreases, the yield decreases. In other terms, it favors backwards. You know, when you increase temperature, it goes to endothermic, right? It wants to decrease temperature, so it goes to the endothermic. And since it's favoring the backward, that means endothermic is the backward. So is the forward endo or exo? Obviously exo. So let's see here. Exothermic, because at the higher temperature, the backward reaction is favored, which is the endothermic one. That's it for chapter 8 sulfur. Thank you so much for watching, and good luck.